So in this video I want to talk to you about the concept of molarity. And to do that we first need to understand what a mole is. So a mole is equal to 6.02 times 10 to the 23rd either atoms or molecules. It's Avogadro's number and it's a constant. So the reason this is beneficial to use is that by using a mole, we can effectively know the certain amount of molecules that wind up in a given solution. So for example, if I have 1 mole of glucose, it means that I've got 6.02 times 10 to the 23rd molecules of glucose. If I've got 1 mole of sodium chloride, it means I've got 6.02 times 10 to the 23rd molecules of sodium chloride. So effectively, this gives us a constant that we can use to ensure that the relative number of a certain atom or molecule is consistent in any of the solutions that we're making. Now understand that when you look at a distinct compound or molecule, for example sodium hydroxide, it has what's commonly referred to as either the molar mass or the molecular weight. And this effectively tells us the number of grams of this substance that are equal to a single mole. So it's the grams per mole. For sodium hydroxide, this number is equal to 40 grams, which means that if I have 40 grams of this compound, I also have 1 mole of that particular compound. So let's take this to the next level. Let's go ahead and take into consideration what a mole is and also bring to light the term molarity. Simply put, what molarity means is it tells us the number of moles per liter of solution. So with sodium hydroxide, if I have a 1 molar solution of sodium hydroxide, that's effectively telling me that I have 1 mole of sodium hydroxide per every liter of sodium hydroxide solution I have. This also tells me that because 1 mole of sodium hydroxide equals 40 grams of sodium hydroxide, that I also have 40 grams of sodium hydroxide in that liter. So, still working with sodium hydroxide, let's look at a few different things. So we know again 40 grams per mole. So let's talk about several different types of sodium hydroxide solutions. Let's say that I want to make a 200 millimolar sodium hydroxide solution in 1 liter. Okay. So here what we're seeing is 200 millimoles comparatively to what we had before, which was a 1 molar solution. Now, millimoles mean 1/1000th of a mole, or molar. So effectively, I can either rewrite this number, or I can rewrite this number so that I'll have the same units. So I need to figure out how this compares to this, so I can figure out how many grams of this I will need to put in 1 liter. So I knew that in a 1 molar, I needed to put 40 grams of sodium hydroxide into that 1 liter to give me that 1 molar. But now I need to figure out how 200 millimoles compares to 1 molar. So to do that, all I have to do is get these into the same unit. So I can either write 200 millimoles over 1,000 millimoles, which is essentially what a 1 molar solution is, or I can write this as moles, where I would just move the decimal over 3 spots. So it would be 0.2 molar over 1 molar. Okay? Now, no matter which way I do this, I'm going to come out with the same answer. And that is that I need to decrease the number of grams down to 1/5 of the amount that I needed to give me a 1 molar solution. So I just need to now take 1/5, since this is my ratio, and I need to multiply that by 40. So 1/5 of 40, of course, is going to be 8. So I would need 8 grams of sodium hydroxide in 1 liter to give me a 200 millimolar solution. All right? Now, let's change up the volume. So let's instead say that I want to keep it as 1 molar, sodium hydroxide. But let's now say that I want to change this to 200 milliliters. So a similar deal here, okay? Essentially, I want to keep it as 1 molar. So that means that originally, when I had 1 molar sodium hydroxide in 1 liter, it was 40 grams. Well, now this is where I'm seeing my discrepancy. So again, I can figure out the dilution, 200 milliliters over 1 liter. This is the same as 1,000 milliliters, so I can rewrite this as either 1,000 milliliters, or I can write this as 0.2 liters over 1 liter, and you'll see that this again comes out to a value of 1 over 5, which means I again can multiply this by this value, and that will ultimately give me the total number of sodium hydroxide in grams that I need to give me 1 molar, which again is 8. So you'll notice, if I only change the molarity, or I only change the volume, there are 2 scenarios, one with the molarity and one with the volume, where I can come out to the same answer for my sodium hydroxide. So now let's look at what would happen if instead of that, I also changed the molarity. So instead of just changing this value or just changing this value, I'm going to change both of them simultaneously. So this time, instead of just changing my molarity or my volume, I'm going to change both. So I want a 200 millimolar solution of sodium hydroxide in 200 milliliters of solution. Okay? So there's several different ways you can approach this. I like to take it step by step. What I like to do is similar to what we did before. First and foremost, I like to figure out how many grams of sodium hydroxide I would need to go from 1 molar down to 200 millimolar. Okay? So, again, we've done this before. 200 millimolar over 1,000 millimoles, or 0.2 molar over 1 molar. In either case, it's a fifth times the number of grams needed to make 1 molar, which is 40 grams. Okay? And that gives me, of course, 8 grams, but I'm not done yet. Okay? Now, I need to look at this, because instead of making a 200 millimolar in a liter, I'm actually now making it in 200 milliliters. And so again, I'm going to take 200 milliliters, I'm going to put it over 1,000 milliliters, or I can also put 0.2 liters over 1 liter. In either case, that's going to be a fifth, but this fifth isn't of 40, it's of the 8 grams. These 8 grams in a liter were going to give me 200 millimolar sodium hydroxide, but now I'm making that in 200 milliliters. So I'm going to multiply 8 by 1/5, okay? And that should give me 1.6 grams. So 1.6 grams of sodium hydroxide would ultimately be the amount that I would need to add to 200 milliliters to give me a 200 millimolar solution of sodium hydroxide. Now there's one final way that we could do this, and if this makes it easier for you, by all means go ahead and do it. If it doesn't, then don't worry about it. Okay, so again, I'm going to erase this. Okay. Now, I'm asking you for 200 millimolar, and I'm asking you for 200 milliliters. Those are both fractions of our 1 molar, 1 liter. So what you could also do is you could convert each of these to their respective base unit of measurement. That is, convert this to liters and convert this to moles. And if you did that, you'd get 0.2 moles and 0.2 liters. Then what you can do is simply multiply these two numbers by each other, which should give you 0.04. So you take the fraction of liters, the fraction of moles, you multiply them by each other, and then you take that number and you multiply it by your grams. If I did this, it will give me the same answer that I got before. Now, just to show you that this also still works with any of the other examples we've done, let's go ahead and change this back to 1 liter, just so that we can see that we're still going to get what we expect to see. Okay, so in this case, this divided by this is just 1. There is no fraction. This, however, is again 0.2 mole. So if I multiply those two, it gives me 0.2, and 0.2 times 40 is going to give me the 8 grams that I saw previously. So if you're comfortable enough with it, the other option you have here is to do these in the base units. That is, if they're in millimoles, then write them in molarity. If they're in milliliters, write them in liters. Now let's see what happens if instead of this, I increase the amount. Let's make sure it works every single way. So let's say instead I want a 2 molar solution of sodium hydroxide in 1 liter. Okay, so that's going to now be 2 over 1, which is 2, times 1 over 1, which is 1, and that equals 2. 2 times 40 is going to equal 80 grams. And let's just verify this. If I have 80 grams of sodium hydroxide over 1 liter, that is equal to 2 moles of sodium hydroxide in 1 liter, which is equal to a 2 molar sodium hydroxide concentration. And so if I wanted instead 2 liters here, I could just plug in 2 liters. That'd give me 2 here, which would give me 4 here, and that would give me 160 grams instead of 80 grams. So you can see if you're comfortable with fast tracking it, this is a way that you can essentially speed up the process of doing those particular calculations. So that's molarity.